Touchscreens have become synonymous with mobile interaction. Likewise, mobile devices typically include motion sensors to support techniques such as automatic screen rotation. To explore techniques for handheld mobile devices that leverage the multimodal combination of touch and motion, we implement a number of interactions using a Zune HD as well as Windows Phone 7. The user can hold a thumb on the screen and zoom in on that point by tilting the device. The rate of zooming depends on the change in the tilt angle. Tilting in the opposite direction zooms out. This affords one-handed continuous zooming, unlike pinch to zoom, which requires two hands. Automatic screen rotation, while useful, makes it hard to surf the web while lying down. But holding the screen while pivoting the device locks the screen at its current viewing orientation. A small padlock icon provides feedback of the state. Rotating to a new orientation automatically removes the lock. Alternatively, in some applications, holding the screen while pivoting the device might be used to rotate objects on the screen about the center of rotation indicated by the thumb. In our prototype photo browser, the user can touch a photo and shake the device to delete that specific photo. Shaking that photo again undoes the deletion. This interaction shows how touch plus motion affords contextual gestures that are specific to an individual object on the screen. To select a region of a photo, the user can frame a portion of the screen with two thumbs, and then tilt the device to crop out the desired region. Moreover, this motion gesture is smoothly integrated with multi-touch zooming. This shows how motion sensing fluidly supports additional interactions while maintaining consistency with existing multi-touch conventions. The preceding techniques illustrated new gestures that are possible when we put touch in motion. But we can also adopt the reverse perspective and instead consider the motion in touch. That is, the sensory ripples that are induced when the user touches the screen. For example, the user can scroll through photos by swiping the screen as usual, but a hard onset to a dragging motion allows one to instead rearrange the photos without resorting to a distinct editing mode. Likewise, from the calendar tile on the home screen, the user can tap normally to view the agenda for the day, and then tap again to navigate to the current appointment. Or the user can instead tap hard on the calendar tile to drill down directly to the current appointment. And the system animates the tile according to how forcefully the user struck it, as sensed by the device's accelerometer, to lend a fresh nuance of expression to tapping. A further possibility is to optimize touch interactions by recognizing the context of use. For example, here we can see that the motions sensed by accelerometers and gyros on the device are quite distinct when the user interacts with a thumb versus a finger of the offhand. Here we see a second example where the motion sensors are used to distinguish which corner of the device a user taps on, without resort to direct touch sensing at all. Collectively, these techniques represent a hidden dimension of touch that hints at how direct interaction is about much more than just touch, and can be greatly enriched by considering the interplay of touch with other modalities, including motion sensing. This can be considered from the perspective of putting touch in motion with new multimodal gestures, as well as from the reverse perspective of seeking the motion in touch to sense subtle nuances of touch interactions.